So what I have set up here, we walk over and explain things. This is still the Pasco thing with the pressure sensor that we used last time. Only this time the pressure sensor is hooked up to this. This is a hollow sphere with gas in it. Well, the gas is just air. I mean, nothing's fancy. And I'll try to think of how to hold it. Okay, got it. This is a solid sphere, and what happens is it's a fixed volume. So we're going to hold a fixed volume of gas, and we're going to measure. We're only going to get we're going to go with 2 data points. We're going to draw 3 graphs, but each with only 2 data points. We're going to have a data point that's at 0 degrees Celsius and a data point that's at 100 degrees Celsius. And we're going to measure the pressure. The 3 lines are going to come from us putting different amounts of gas into here. So we're going to do that curve that I showed where everything extrapolates down to absolute 0. I put the lab online. The lab has other things in it too, but just use it for the gist of what to do. You're going to draw 3 curves and get a value for absolute 0. So how are we going to get different moles of gas in here? Well, we're going to put the gas in at different temperatures. So if I put gas in when it's room temperature, then this is still kind of, when I put gas in when it's room temperature, or the temperature of, I'm sticking it in just regular tap water right now. You can't see off the screen, but if I put gas in while it's just at, roughly 20 degrees, I don't know exactly what temperature, and then that's going to be 1 molarity. So for graph number 1, we have 1 amount of moles. We're not going to calculate the amount of moles. It's just that it's going to make the slopes different. So here's what we're going to do. You need to record this data, and I'll write it down too. 2 data points. This is run number 1. 2 data points. We're going to get temperature and pressure. Oh, I need to start the where am I here? Start the recording. Okay, now we're good. So we're not ready for that one yet. So I'm going to put this in cold water and wait a moment for the pressure to come to equalize. So run number 1, 0 degrees Celsius, 93.4 kilopascals. All right. Still run number 1. Data point number 2. Well, maybe I need to bring this a little closer here. 100 degrees Celsius. This water is actually boiling. We're just going to assume it's 100. I'm not measuring the temperature of the water. I guess I could do it afterwards and just sort of confirm. Wait till we get an equilibrium. Oh, I don't want to touch I was touching the bottom of the thing with it. So 126.0, 100 degrees Celsius. Okay, so now I'm going to go for run number 2. So this is going to be a separate line on the graph. I'm going to put this into the hot water, wait till it comes back up again to equilibrium. And I'm going to open it. I'm going to take this tube off so the pressure equalizes. Now it's back down. Now it's really hot, but it's at 1 atmosphere of pressure, roughly 103. That's going to actually be one of our data points once I get this back on. This is where it's good to have a third hand. Okay, so second run, 100 degrees Celsius. I see a chat, but I can't get to it yet, but I will in a minute. 100 degrees Celsius. If you ask a question verbally, I'll answer it. 100 degrees Celsius, 101.6 kilopascals. There we go. Had to came up. So now it's under equilibrium. 101.6 kilopascals, 100 degrees Celsius. And then still run number 2. 0 degrees Celsius. .6 kilopascals, 0 degrees Celsius. I guess it's still getting colder. Oh, that's because it's partially out and there's an ice cube sitting on it. Let's go back. I'm going to change that to 74.8 instead of 75.6. I don't know. There could be that there's gas equalizing or something too. All right. Run number 3. I'm going to put a different amount of gas in it again, a different molarity, by opening it up while it's cold. So wait a minute for it to come. So again, I'm going to make it cold at 102. So I'm gonna put this back on here. So second run, third run now, 0 degrees Celsius, 100 kilopascals. And third run, this will be the last run, and that's the data will be taken. 134.8 kilopascals, 135. Oh, it's just, my hands in the steam, starting to get hot there. 135.2 kilopascals. 1, 2, you decide. 100 degrees Celsius. Here is a summary of the data.